welcome. This is going to be our lecture video for March 24th, 2020. Today we're going to be going over factorials. So let's just recap our last lesson a little bit by doing 21 and 22 from the last worksheet really quickly. Problem 21 gives us the start of an arithmetic sequence and asks us to find the 23rd term. That little subscript there means find the 23rd term. We know this is arithmetic because as we move from number to number, we're adding the same amount each time. We are adding a negative 30. And if we just keep adding a negative 30, if we do that all the way out to the 23rd term, this being the first term, the second term, the third term, what do we get? Well, we can use our explicit formula for that. And to do that, you take the first term plus our common difference times this number, 23 minus 1. All right, and that's because if this, we wouldn't have to do that minus 1 if we called this the 0th term, but because we want to call this the first term, that's why that minus 1, everything gets shifted 1 over, just so you know. All right, so let's see what we get here. 34 plus a negative 30 times 22. I can turn that plus and negative into a minus. And do 34 minus, well, 30 times 22. I can do that now. 660. And then 34 minus that is negative 626. All right, let's look at this one. First, we got to find that common difference. With the negatives, maybe it's a little bit harder to figure out what the common difference is. So just do a sub 2 minus a sub 1. So I'll do negative 33 minus a negative 24. Just going to plug that exactly like that is into my calculator. And to find that my common difference is a negative 9. And now I look back at the sequence. Yes, that makes sense. It looks like we're going down 9 each time. So that's my D. So now I can do my first term plus my common difference times the term number we want minus 1, negative 24 minus 9 times 30, negative 24 minus 270, negative 24 minus 270 should be negative 294. Okay, so that's a little recap of arithmetic sequences. Goal for today is to understand the definition of a factorial and how to simplify expressions containing them. And we're going to see a couple of tricky ones. So even if you think you know everything there is about factorials, I bet I'll show you a tricky problem at the end here. So why we're doing this, factorials appear in many useful sequences or are very useful in probability problems. That's our next unit. So once we finish sequences and series, we're going to move on to probability, so we're going to need this. Hopefully you've already got your notebooks out, ready to go, today's date. If you want to follow along in your textbook, it's page 390. You can see some more problems there. Otherwise, just pay attention to this PowerPoint. You should be fine. All right, so what is a factorial? All right, here's our definition for our notes. A factorial is the product here mean the result of multiplication of all of the whole numbers less than or equal to a number. And it's signified by an exclamation point. All right. When I say whole numbers, I'm not including 0 here. Obviously, if you included 0, then everything would go to 0. But yeah, this is best learned by example. So here we say this as 6 factorial. So you read the exclamation point as factorial. And what 6 factorial means is it is the product of, well, we can do it in either order. I don't like to do it in ascending order. 1 times 2 times 3 times 4 times 5 times 6. And I can plug that into my calculator, or, well, why don't I'm going to plug that into my calculator, then I'm going to show you the shortcut. Let's pull up the calculator here. Alright, so I can do 1 times 2 times 3 times 4 times 5 times 6. That took a while to plug in, but I get 720. 6 factorial is 720. These numbers grow really fast, you'll notice. Or I can do 6 math, and then it's over under number. Oh, it's not. Where is it? Oh, it's no, that's the first one. Oh, where is factorial? Everyone's probably screaming at me right now. Use it all the time. Maybe it's under number. Oh, it's under prob. There it is, number 4. Alright, so even though I forget, but there we were able to search and find it. 720, same answer. So let's add that back to our notes here. 720. So 6 factorial equals 720. All right. And let me just say, if I wanted to find 7 factorial now, I wouldn't have to do the 1 times 2 times 3 times 4 times 5 times 6. I could just say this is 6 factorial times 7 and just multiply this by a 7, because the 6 factorial is going to be within 7 factorial, then it's going to get multiplied by a 7. Okay. Special cases. 0 factorial, this is a really important one to remember, is just equal to 1. It doesn't quite make sense because it just seems like it should be 0, but it makes all of our probability formulas work if we just define 0 factorial to be equal to 1. So that is a special case. You just got to memorize it. All right, can we take the factorial of 3/7? We cannot. It's undefined. Only works, it's an operation that only works on our whole numbers. What about a negative number? Can we take the factorial of -8? Also undefined. So it's very limited range here. And that's okay, because when we use it, it's always with whole numbers. All right. This we can do, 7 factorial divided by 5 factorial. So I'm going to show the simplification technique. What you're going to write out, so just copy down a problem initially, is you're going to write out all of that multiplication. And eventually you won't have to do this, but for right now it's good. So 7 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7. 5 factorial just stops at 5. Now, because everything's being multiplied, we can start canceling. The 1s cancel, although they didn't really change anything. 2s, the 3s, the 4s, the 5s. And we're left with just 6 times 7. We can just do that in our heads, that's 42. So 7 factorial over 5 factorial, even though I don't know what 7 factorial is, I can still find the answer by doing canceling before I do the multiplication. All right, and so now that you start seeing these problems, you can start splitting this differently. You could say 7 factorial is equal to 5 factorial times 6 times 7, and then just cancel the 5 factorials directly. But for right now, it's not a bad idea to write them all out. All right, but what about when it's algebraic? So here's something we can say. N factorial is equal to, and we're going to go in reverse order here, n times n minus 1 times n minus 2 times n minus 3. So if I was doing 7 factorial, I'd do 7 times 6 times 5 times 4. That's what I would get if I completed that subtraction. Dot, 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 for however big n is. We don't know how big n is. But at some point, we could say, well, we'll just stop this process and say, wherever we stop, we'll just put the factorial there. So we pulled out the biggest terms of this factorial, and we're just going to leave the smaller number just factorial. So like, for example, 7 factorial could be split into 7 times 6 times 5 factorial. Or I could keep going. I could go down to 4 factorial and then just keep moving the factorial down. All right, so let's see this with this problem here. So this just kind of notes. Now it's time to do that problem. N factorial over n minus 1 factorial. Well, I'm going to start backing up this n factorial on the top. I'll split that into an n times n minus 1 factorial. So I'm shrinking it. The factorial moves to the end. But once I just move it one time, I see that I can do a big bit of canceling. The n minus 1 factorials can cancel out. And I'm left with just n. So n factorial over n minus 1 factorial will always be equal to n, regardless of what n is equal to. N just has to be bigger than, I guess, 1 here, or bigger than 0, because if you plugged in a 0, you'd get negative 1 factorial, which is undefined. All right, what about this one? N minus 1 factorial over n minus 3 factorial. So which one is bigger? Is n minus 1 or n minus 3 bigger? Well, the n minus 1 is bigger, so we're going to start backing that one up. So we'll take that n minus 1, subtract 1, make it n minus 2 factorial. Well, nothing can cancel, so we'll back it up a little bit further, n minus 3 factorial. Now I can do some canceling with the n minus 3 factorials. And I get just n minus 1 times n minus 2 equals 30. I'm going to have to FOIL that. I get n squared minus 2n minus n plus 2 equals 30. Subtract the 30 from both sides. I get n squared minus 3n minus 28 equals 0. And now it's time to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That becomes 3 plus or minus the square root of 9 minus 4 times negative 28 all over 2a. Remember, I said do as much the quadratic formula that you can in your head to save steps and avoid mistakes. 3 plus or minus the square root of 9. Negative times negative is going to be positive, so 4 times 112 all over 2 plus 3 plus or minus the square root 121 all over 2. Square root of 121 is 11. Let me double check that. Yep. So I can split this into the two cases, 3 plus 11 over 2 and 3 minus 11 over 2. This becomes 14 over 2, which becomes 7. This becomes negative 8 over 2, which becomes negative 4. Do both of these answers work, though? If I try to plug in a negative 4 right here, I'd be taking the factorial of negative 5. So this answer here we could cross out as extraneous, and 7 is our only answer. So final answer, n equals 7. And you can double check that if you want. Plug in the 7, make sure it works. Not a bad idea. All right, time to work on that worksheet. Have a good rest of your day.